So we know how to simplify numbers, at least inside radicals, but right now we're going to be simplifying variables inside radicals. It's as simple as this. We already know that when you're multiplying inside a radical, you could split the square root. And the square root of 4 is what? And the square root of x squared. At the beginning of the week, I mentioned that a square root is the opposite of a square. They're opposite math operations. The square is the opposite of a square root. The square root is the opposite of a square. So they undo themselves. It's like me saying x plus 3 minus 3. The plus 3 and minus 3, those are opposite operations. They eliminate themselves. So when I say what's the square root of x squared, it's just x. The square root disappears. All right? Let's move on to number 2. And what do you guys say the answer is? 3yi or 3iy? Sure, that's good. Using or showing the work, split the root. And we all know that the negative inside the root, that's going to produce an imaginary answer. So you will have the square root of 9, but with an I on the outside. And we know that the square root of 9 is really 3. So we have I times 3 times, and we just said that when you do the square root of anything squared, the square root and the square eliminate themselves. So you have y as your answer for that part. So your final organized answer, you always want your number first, your letters next, and the imaginary variable I at the end. So 3yi is the best answer for number 2. Let's move on to number 3. Let's split the root on number 3. We're going to have the square root of 12 and the square root of x squared. Which one's the easiest to do? 12 or x squared? X squared. What's the answer there? That's just a regular x, right? Now 12, you actually have to do some work. You either use the factor tree method or you use perfect square numbers. So I'm going to go with 4 times 3, and I'm going to split the root. So my answer will be 2 square root of 3 times x. X is not on the inside of the square root, it's on the outside. So the best answer would be to organize it. 2x square root of 3. Perfect. 2x square root of 3. Last question. We have negative 3 out in the front times the square root of negative 40 times the square root of x squared. We're splitting all the square roots. We end up with, this one's easy. What's the square root of x squared? That's just x. Now, the hard part is the square root of negative 40. It's not the hard part. It's just you have to do some work. We do know that this negative sign is going to become an I on the outside, and you'll have 40 left over on the inside. Let's not forget about the negative 3 that's out here in the front. So I really have negative 3 times I times the square root of 40 times x. Let's do the square root of 40 by rewriting it 4 times 10, and then splitting the square root to each of them. And what is the square root of 4? 2. And the square root of 10, you're going to leave it the square root of 10. And of course, you're going to bring down everything else. You're going to bring down this negative 3. You're going to bring down this I. And you are multiplying between everything. And we're also going to bring down this x. So all we need to do is organize it. So on this slide right here, we see that the key concept, a square root can be written as the power of 1/2. Again, any square root, you can rewrite it as the power of 1/2. So the square root of x is really equal to x to the 1/2. So you could change this to look like this. Why would we do that? I would not. If I had the square root of x, I would just leave it the square root of x. Unless they tell me to write it as an exponent, then it would be x to the 1/2. But this fact right here does come in handy when I'm taking the square root of a variable to a certain power. Like number 1, I have the square root of x to the 8th. So I know that a square root, this square root right here, can be rewritten as the power of 1/2. So instead of the square root of x to the 8th, I could write x to the 8th to the 1/2. Now, if you guys remember from last week when we did exponents, what was the rule when you had a power to a power? What would you have to do? Power to a power. Multiply. Now, if I did say, what's 8 times half? What do I get? 4. I get 4. So in reality, I have x to the 4th power. And ladies and gentlemen, that's my answer number 1. The square root of x to the 8th power is simply x to the 4th power. So, number 2, it would be wise, whenever you have multiplication on the inside with the square root on the outside, you might as well split the root to each of the terms. So I've split the root. The square root of 25 is 5, and the square root of x to the 4th. Now, does anybody know what the square root of x to the 4th is? 2. X to the 2. Now, of course, I'm going to show my work. So I'm going to rewrite the square root. I'm going to rewrite it as parentheses to the power of 1/2. And the x to the 4th, it's going to be right in there. Remember, the square root can be rewritten as a power of 1/2. And when we have a power to a power, what do? You multiply. So 4 times half, what's half of 4? 2. So your final answer is really 5x to the 2nd power. And that's it. Now, like I said, you're not going to have to show this work all the time. It's going to be this easy, Andrew, that if you have an even power up there and you have a square root, you're going to end up just dividing it by 2. You're going to divide the power by 2. That's the easy way to do it, right? So I'm pretty sure a lot of us could see number 3 and just say the answer. What would the answer be?
3x to the 2nd, y to the 3rd.
We forgot about that negative on the inside. 3i x to the 2nd, y to the 3rd, z to the 1, or nothing right there, right? That's the answer. Let's put the I at the end. That'd be the best one. 3x squared y to the 3rd z I at the end. Now, I didn't show any work. I'm going to show my work because this is the first time we see this. So, of course, whenever you have multiplication on the inside, split the root to each of them. So you're going to have, there's my root split into each one, and then we're going to do each one. The square root of -9, we already know that that's 3i. The square root of x to the 4th, we know that's the power of half. Half of 4 is 2, so x squared. The square root of y to the 6th, we already know that the square root is really the power of half. Half of 6 is 3, so you have y to the 3rd, and also z to the 1. So there's your answer. All we need to do is move that I and move it to the back. Put the I out here. So your final answer is 3x squared y to the 3rd zi. Let's try another.
X to the 6, y to the y has nothing. Z to the 8. No, z to the 4.
Let me show my work and we'll get it. Check it out. Square root of x to the 12th. And then square root of y. And then square root of z to the 8th. So we all know that the square root of x to the 12th, what is that?
6.
X to the 6th. Now, what is the square root of y? You just leave it, right? You just leave it. So that really is the square root of y. But how about the square root of z to the 8th? That's z to the 4th, no more square root. So we just need to rearrange it. Yep. There's your answer. Good question. I'm going to record this. If you have a bunch of letters, A, B, and C, you want an alphabetical order A, B, C. If you have X, Y, Z, you want an order X, Y, Z. But you always want your letters first, and then the imaginary if you have it, and then the radical at the very end. So because Y is a radical, that's why we put it at the very end instead of in between. Challenge. There's many roads to the same place. We could do this many different ways. I want to explain it the quickest way possible, but I want to give you guys a chance to do it on your own first. Okay, guys, so to be honest with you, the first time I did this in the morning, in my morning class, I actually broke down, did the square root of -8, the square root of x, the square root of y squared, the square root of 18. I broke it all down and rewrote it. But see, here's the quicker method. You guys remember you could split the root or you could put them back together, right? So this is what I'm going to do. I'm going to rearrange everything. Negative 3 times 2 times the square root of. So I just rewrote it, put the numbers first and the radicals together or right next to each other. And now I'm going to multiply this radical with this radical and put them under the same radical. Does that make sense? Now, you guys have calculators. If I did negative 8 times 18, if I did this negative 8 times this 18, I believe you get negative 144. Is that right?
Yeah.
Okay. If I did do the x times this x, what do I get? X squared. And if I did do this y squared times this y squared, what do I get? Y to the fourth. You're right, y to the fourth. Okay, and of course on the outside, I have the negative 3 times 2, that is negative 6, that I'm multiplying by. Now, on the inside of this root, I'm going to split it now. It's going to be the square root of negative 144, the square root of x squared, and the square root of y to the fourth, with the negative 6 out in front. Now, what is the square root of negative 144, which happens to be a perfect square number? 12i. This is 12i. Now, what is the square root of x squared? X. And what is the square root of y to the fourth? Y to the second. So now let's just rearrange it. Put this I at the very end. So my final... Oh yeah, what about the 6? Good call. This negative 6, I need to also bring it down and multiply.
That was a close one.
Close one. So 12 times negative 6 is negative 72. And then you have the x, the y squared, and the I at the very end. And that was a challenging problem that doesn't look so challenging. Now, if we did it the other way, splitting the roots, then it does become very challenging.